Welcome back, Algebra 2 students, to Mr. Khan's videos. Today we're going to be doing 1.5, which is solving literal equations. So a literal equation can consist of some numbers, but typically what happens is a literal equation has many variables. And because it has many variables, we can arrange it in many different ways. When I'm saying solving a literal equation, that means that I actually want to solve it for a specific variable. So when I say what is a literal equation, an equation that contains at least two variables, and usually models something in the real world. So we have classic ones like temperature change, so Celsius and Fahrenheit and Kelvin. Those all actually have equations to go from one to the next. Okay. Other things, euros to dollars to yen, money transfers, right? Currency. Things like conversions between units. Okay. All these things are known as literal equations, which you can see here, I got a few down for you. I am not going to print this sheet off for you, nor am I going to give you it on the test. You should know most of these. You should write them down right now or print them off. Okay, they are in a static copy as well. Now it says solving for specific variables. I want to solve this first equation right here for D. So when I'm looking at that, I see that these right here. I am treat everything else like a number. So when I'm looking at this equation, C times D equals E. If I want to get D by itself, this C is in the way. What's the C doing to the D? It's multiplying it. It's multiplying. So I divide by C. If I divide one side by C, I divide the other side by C. These will cancel. I will have just the D left over here equals E over C. Notice I don't have numbers. So this is as much as I can do. I wanted D by itself. And I got it. So I'm done with that. Well, let's try another one. It says solve for G on this one. Well, G's over here. Now, this is the tricky part for most people. I'm treating everything else like a number. So if I were to make one up, like this is 34 minus 7G equals 14. And I told you to solve that for G. That'd be no problem. I bet you each and every one of you in here would dominate that problem. You would subtract 34, right? You get negative 7G equals some number over here, so that's 14 minus 34. And then you would divide by negative 7, and that whole side you divide by negative 7. And somehow you get G equals 14 minus 34, all divided by negative 7. Of course, those are numbers, so we could do that. However, I do not have straight numbers up here. If I grab this, pull it down, and rewrite it for you, that's 5F minus 6G equals 14. And I am trying to solve for G. Just look at what we did up above. What did I do with the 34? Well, I moved it. Think about the 5F is one giant number. It's positive now. To move it, I just need to do the opposite. Subtract. Okay, that'd be a 6G, negative 6G left on this side equals, that's 14 minus 5F. You say it like that, just write it like that. How do you get rid of that negative 6? Oh, well, you divide by negative, or I'm sorry, put a G down there. You divide by a negative 6. Oh, what you do to one side, you do to all of the other. And I have, oh, these 6's cancel. I have G equals 14 minus 5F all divided by a negative 6. This answer is completely sufficient, right there. It is completely sufficient. All right, let's try one more. Give you a second here to write down the question. All right, now let's try to do this. If you remember back all the way in section 1.2, I said there are two different ways to solve these fraction problems. Way one is you keep fractions, you're keeping them, and way two is you get rid of them. Okay, one way I get rid of them, the other way I keep them. Most of you, I think, want to get rid of them. If you get rid of them, though, if you elect to go with option 2, you have to find an LCD, at least common divisor. What's the first thing that 7 and 3 hit because they're in the denominators? Well, the least common divisor between 7 and 3 is going to be 21, so I have to multiply this thing by 21. Well, okay, if I'm multiplying by 21, I'll show you guys what that looks like again. This is 4/7 m plus 2/3 n equals 24. If I'm multiplying by 21, everything is being multiplied by 21. Every single thing is being multiplied by 21. All right. Well, I know 7 and 21 cancel, leaves me with 3. 3 times 4 is 12m. 21 and 3 cancel, that's a 7. That's plus 14n equals, now I got to do some math here. This is 24 times a 21. Let's see if we remember how to do this stacked multiplication. You take 1 times 4, that's 4. 1 times 2 is 2. Then I go to the next one, well, I have to put a 0 down here. That's 2 times 4, that's an 8. 2 times 2 is 4. Then I add these. That's 4. Oh, that's a 4 over here. 0 with a 1 up here, which makes 504. Oh, 21 times 24 is 504. Look at that. I got no fractions. No fractions. Got rid of it. Now I go back to the original problem and says solve it for n. Well, n's right here. That means I don't want this 12n. So I take the 12n away. Take it away. Well, that's 14n equals 504 minus 12n. I can't actually subtract those. They're not common. They're not like terms. All right, then what do I do? What? Divide by 14, divide by 14. Now this right here, technically is our answer. Problem is, I don't think it's simple. It's not simplified. Because 504, 12, and 14, do they share any numbers? Oh, they're all even. So guaranteed, at least 2 goes into each one. Well, 2 would go into 504, what, 252 times? You're going to 12 6 times and 14 7. So that would leave me with n equals 252 minus 6m divided by 7. Well, does 7 and 6 share anything? No? Okay, well then it doesn't even matter if 7 would go into 252 because I'm stuck right here. And there I have another literal equation. Here I think I'll do a few finding value problems. This should not be hard. I think I'll only do this one just because I think it's very straightforward for you. And then that's going to complete section 1.5. So I have x equals negative 5. Okay, well x is going to be negative 5. Well, x is right there. So I'm going to take 2y minus 5 times a negative 5 equals 12. Well, that's 2y equals, or I'm sorry, 2y plus 25, because negative 5 times a negative 5 is a positive 25. I subtract, I would get a negative 13. I divide, I get negative 13 halves. And there's my answer. So when x is negative 5, y is negative 13 halves. Which we have written like this before, negative 5 comma 13 halves. That's known as an ordered pair. In ordered pairs, we always go alphabetically. What happens if I try this 0? Well, I do the same thing. 2y minus 5 times 0 equals 12. Well, that's 2y equals 12 because 5 times 0 is 0. Y would then equal 6. Well, that pair is 0, comma 6. And I think I'll read the last one for you. I don't need to go through that. I think you guys are smart enough to figure that out. And that completes section 1.5, literal equations.